Hi, this video will focus on answering the question, does the relation represent a function? Well, before we can figure that out, we need to know what a relation is. So I wrote down the definition over here. A relation is a set of ordered pairs, all right? Like I have here in red, ordered pairs, 3, 2, that's one ordered pair. And you remember what ordered pairs are. If you draw the Cartesian coordinate plane, and you were to graph the ordered pair, you go to the right, 1, 2, 3, and up 2, right? And there's your point. So each one of these ordered pairs represents a point on the coordinate plane. Okay, well, how do we know if this is a function or not? Well, in order to determine that, we have to understand a couple more things first. What is the domain of a relation? Well, it's the first component of each ordered pair. Or, to make it simpler, it's the input, or the inputs. The first component is the input. We input 3 and we get out 2, right? Input 4, get out -1, input -1, get out 3, so on. Okay, well, if that's the domain, then what is the range? Range is the next thing we need to understand. That would be the output. Well, that was easy. We got input, output. It's like putting something into a machine and getting out something else. Or maybe the same thing comes out. Never know. So the domain of our relation here would be 3, 4, -1, and -2, right? We're just listing all of our inputs. It's pretty easy. 3, 4, -1, -2. The range would be our outputs. So 2, -1, 3, -5. And yes, you can have an input that is the same as an output, that's fine. Okay, but how do we tell if it's a function from all this that we just learned? What is a function? Well, it's a relation in which each possible input, which is a domain, leads to exactly one output. Okay, 3 leads to 2, 4 leads to -1, -1 leads to 3, and -2 leads to -5. What does that mean? Exactly one output? Well, what if we put in 3 once again to this, relation? What would we get out? That is the question. If we get out 2, then we have a function. If we get out anything else, any other number in the infinite set of numbers, then it is not a function. Why is that? Well, it's the same input, right? If you put in the same thing and you get a different result, then it is not a function. Because every time you put in 3, you should get out 2 in this relation. Every time. Remember Einstein's definition of insanity? Doing the same thing and expecting a different result? Well, that's what I use to remember how to recognize whether a relation is a function or not. If we do the same thing, same input, and we get a different result, then this function is, this relation is insane. We all have one relation that's insane, don't we? Anyways, then it would be dysfunctional, therefore not a function. So if we added, say, 3, -2 to this this relation, then it would be not a function. No, it would be a no, but we didn't. So the answer is yes. This relation is a function. All right, let's do another example. We have a new relation here in green. -2, -2. Okay, let's write down the domain and the range first before I start going into all the different points here. -2, 0, 2, 0 again. That's important. And 3. Okay. Range, what's the range? -2, 2, 2 again. -1, 4. Okay. Now, can we answer if this is a function? Yeah. The only thing that matters is if we have a repeating input. If we didn't have a repeating input, then we could automatically say, yes, this is a function. But since we have a repeating input, we have to check to see if that input gives us the same output. And one of them, or each of them, gives us a different output. If, if both of these had said -1 or 2, +2, then it would be fine, but one of them gives us a +2 and one of them gives us a -1, so no, this is not a function. All right, I got another example here. Another relation. What is our domain? Okay, 5, 2, -3, and 5 there. Okay, we have two inputs that are the same. Watch out. What is the range? 7, -8, -8, 7. Okay. Is this a function? Well, let's see. 5 goes to 7. 2 goes to -8. -3 goes to -8. And 5 goes to 7. That same input leads to the same output. Therefore, it is a function. Does it matter if we have two different inputs that give us the same output? No. No, 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 no. That is okay. All right. One more example for the road. Although this example will have two parts to it. Okay. First of all, this is a little different from the ordered pairs we've been doing before. This time, we are going to look at this menu for a, cafe. And let's say the item is the input. All right. Is that a function? When the item is the input. Let's see. We have 3 inputs, all of them different. So I think it's safe to say this is a function. Soup, salad, sandwich, right? And the prices, $2.99, $2.99, and $3.99. Yeah, that's a function. We don't repeat any of the inputs, so we're fine. But what if the price is the input? Let me just grab a different color marker here. Price is the input. Is that a function? Well, I don't know. Let's see. $2.99, $2.99, $3.99. Maybe if you were ordering from a through a computer somehow, and you just told the computer you wanted an item that it was $2.99, what would you get? Would you get soup or the salad? If the programming on that computer is not, very good, then you may not know which one you're going to get. They'll just give you whatever they want to give you. Maybe you don't care. maybe you just want something to go with your sandwich. But we have the same input and we have two different outputs. You can't expect a different result. That is dysfunctional. So no, this is not a function. Just write out the whole thing. Not a function. Thank you for watching.